สวัสดีครับ hello everybody สวัสดีครับ hello everyone สวัสดีครับ so we're gonna do the live in English language today and because I haven't done a live in English for a while and today we're gonna do a little method, a little calculation maybe, and I was thinking we'd do something about physiology. I did a little diagram here. We'll get to this in a second, but yeah, as I said, like I like to do these tutors in the English language because English is universal language of medical education, and for those of you who wants to practice USMLE or do the board questions and tutoring like that, it's good to do it in English because of course USMLE is in English, right? So it's good to practice your English as well. And as I said, like these USMLE questions and board style questions, medical education in general is very it takes little brain. You don't have to be an Einstein. You don't have to be a genius to master these concepts. But the key to these things is repetition and just being disciplined in your study. You're gonna sit there and go over the concept again and again and again. And you have to have that thirst. You have to have that thirst for knowledge and thirst for medical education. And as most people know, as you guys know, my passion is medical education. The aspect of medicine that I like the most is actually medical education because I'm addicted to these medical concepts. I'm addicted to these like medical education. Like to me, medical education is a craft. I get goosebumps when I talk about it. It's a craft that you should pass it on to somebody else, the next generation. You have the ability to educate the next generation of doctors, and that's the thing that makes me addicted to making these videos, to dedicate my time to the next generation. So today we're going to do some physiology, and physiology is a very important subject in medicine. It's one of the key subjects, especially if you're studying for USMLE Step 1. Physiology is like you study the human body, like the normal function of how it works. And then you go on to study like pathology or something like that. But to study pathology, the ailments and disease and stuff like that, you have to know how your body normally works. You have to know like how does a body works normally. So I'll give you an example. For the heart, you have to know, let's say, a normal stroke volume, a normal cardiac output of a heart. That's physiology. That's normal physiology that you should know. And then after that, if you go and study pathology, right? You study pericardial effusion or cardiac tamponade when the blood is in the pericardial sac, and it prevents the heart from dilating. It prevents the heart from pumping properly. So the stroke volume will go down, cardiac output will go down, but you have to know how the heart works normally first to be able to know, the pathology part of it. So physiology is the most important, to do well in your step 1, to get, 230, 240 plus, you have to master your physiology. And today we're going to do the physiology of the heart, just normal stuff, important stuff. And I'm going to read you the questions that I have right now. We're going to calculate something today. I'm going to read you the question, and then I'm going to explain the concept, And then after that, we're going to do the questions together. I'm going to work out the question. You're going to see exactly how I work this question out. I like my trains of thoughts, okay? So, a cardiac question says, if cardiac output is 5.2 liter per minute, heart rate, the patient's heart rate is 76 beat per minute, and end diastolic volume is 145 milliliter. What is the end systolic volume in milliliter, right? So it's asking you to calculate the end systolic volume. And real quick, I wanna just explain this real quick again. So in the heart, systole is when the heart pumps, and diastole is when the heart relaxes, dilates, and receives blood, right? When the heart pumps, systole, the heart's pumping blood, from the left ventricle, like the oxygenated blood that's full of nutrients to the rest of your body. So when we look at these cardiac cycles, we generally just concentrate on the left ventricle, right? Left ventricle of the heart. So again, the heart has 4 chambers, right? Right atrium, left atrium, right ventricle, left ventricle. The blood comes, the deoxygenated blood, the blood with not a lot of nutrients, the blood's been used up. The blood that has low oxygen supply will come to the right atrium. Then the right atrium will pump that blood to the left ventricle. Left ventricle will pump that blood to the lungs, where the pulmonary arteries, right? And then when the blood gets oxygenated, it will come back to the left atrium and then left ventricle. And left ventricle will pump that oxygenated blood to the rest of your body. And the rest of the body needs oxygen, right? So blood with oxygen is so important. And when we concentrate on these cardiovascular physiology, mostly we concentrate on the left ventricle. The chamber that will pump that oxygenated blood to the rest of your body. And cardiovascular physiology, we concentrate on 3 main things, right? The 3 main things are stroke volume, ejection fraction, and cardiac output. And this is like the bulk of the question of cardiac physiology will come from these concepts: stroke volume, ejection fraction, and cardiac output. And as I said, when we look at these concepts, we concentrate on the left ventricle mainly. And so stroke volume, what is it? Stroke volume is the volume of blood that the left ventricle pumps to the rest of your body, and it basically measures the blood that leaves the heart by beat, right? It just so it looks at how much blood leaves your left ventricle and goes to the rest of your body. It looks by beat, okay? So it takes in account of the volume of blood that leaves the heart by beat, systole, right? And so that's stroke volume. Stroke volume is the volume of blood that leaves the left ventricle by beat. And how does that work out? Stroke volume, the formula for stroke volume is end diastolic volume minus end systolic volume. So the difference between end diastolic volume and the end systolic volume. So what are these 2 values? The value of end diastolic volume and the value of end systolic volume. Diastole, right? Diastolic volume. Diastole is when your heart relaxes and your heart chamber, the left ventricle, receives blood from the right atrium. And at the end of that cycle, when the heart relaxes and receives blood, and when it's filled with blood, the left ventricle is filled with blood, that's end diastolic volume. And end systolic volume is when the left ventricle pumps that blood to the rest of the body. And when when the left ventricle pumps up blood to the left body, when the blood leaves the left ventricle, that's called the end systolic volume. So the stroke volume is the difference between end diastolic volume and the end systolic volume. So stroke volume is end diastolic volume minus the end systolic volume, and that's stroke volume. And as I said, basically stroke volume is how much blood leaves the left ventricle after each pump, right? After each pump, how much blood leaves the left ventricle and goes through the rest of your body, right? That's stroke volume. And ejection fraction, what is that? Ejection fraction measures the efficiency of how your ventricle is contracting, basically, and it comes in fraction, right? So stroke volume divided by end diastolic volume. That's ejection fraction, and it makes sense, right? So stroke volume, how much blood is leaving the left ventricle after each beat, and end diastolic volume is how much blood fills up the left ventricle before it pumps out. So it gives it a fraction, and a normal ejection fraction, how normal like contracted the heart, it's around 55%. And this is really useful for doctors when you look at the heart, because if the ejection fraction is like less than 55%, that means the contractility of the heart has some problem. That means that the body will not get enough oxygen to the brain or to the rest of the body. And usually when the patient has heart failure or something like that, the ejection fraction will be less than 55%, and that could be a worrying thing for the doctor. The doctor will be like, oh, maybe this patient isn't getting enough oxygen to the rest of the body. He's having heart failure, or maybe the patient has cardiac tamponade, or has pericardial infarction or something, pericardial effusion or something, where the contractility of the heart has some problems. So this is very useful thing for the doctor to see if the heart is working properly, if the patient has heart failure or something like that. So ejection fraction, stroke volume over end diastolic volume. And one more important thing before we will do the question today is the concept of cardiac output. And cardiac output is the total of the blood that leaves the left ventricle so the blood that left the ventricle that would go to the rest of the body. The volume of blood that leaves the left ventricle per unit of time. So usually, basically, like the blood that leaves the left ventricle per minute. So this is different from stroke volume, right? Stroke volume measures the blood that leaves the left ventricle per beat, right? Cardiac output measures the blood that leaves the left ventricle per minute. So this measures the volume by time, and stroke volume measures the amount of blood that leaves the left ventricle per beat. Okay, so we have some basic concepts down, and now we're gonna do a question. A question, as I said, it wants to know the end systolic volume, right? So the question says cardiac output is 5.2 liters per minute. The heart rate of the patient is 76 beats per minute. End diastolic volume is 125 milliliter. What is the end systolic volume? So the question asks like when the heart pumps, when the left ventricle pumps the blood out to the rest of the body, how much blood is left in the left ventricle? So it wants to know like how much blood is left in the left ventricle when the heart pumps. When the heart pumps, the blood goes to the rest of your body, but how much blood is remain in that chamber? How much blood remains in the left ventricle? So what is the end systolic volume, right? So I'm gonna write down the numbers that we have. Let me highlight that actually. So cardiac output of this patient is 52 liter per minute. The heart rate of the patient 76 beat per minute. End diastolic volume is 145 milliliter. What is the end systolic volume in milliliter, right? So here's what we're gonna do. I'm gonna write everything down that we already know, right? First of all, they want the end systolic. So what is the end systolic volume? How much blood remains in the left ventricle once the blood is pumped out, right? And what do we know? Cardiac output is 5.2 liter per minute. So cardiac output 5.2 liter per minute. And actually, the answer wants this in milliliter, right? So we're gonna convert 5.2 liter to milliliter, and that's actually very simple. You move the decimal 3 places behind, right? So cardiac output 1, 2, 3 milliliter. So cardiac output 5200 milliliter, right? Heart rate of the patient is 76. Heart rate 76 beat per minute, right? What else? So N diastolic volume is 145 milliliter. So end diastolic volume 145 milliliters. So that means that when the left ventricle dilates, when the left ventricle receives blood from the left atrium before it pumps the blood out, the blood in the left ventricle has this amount, 145 milliliter. Okay. So and by the way, yes, this is per minute, per 1 minute. Cardiac output 5,200 milliliter per minute, right? So it asks what is the end systolic volume. So it gives us all these information, and it wants us to work out the end systolic volume. So it wants us to work out how much blood is in the left ventricle after the left ventricle pumps blood to the body. How much blood is left in the left ventricle? And as I said, cardiac output of this patient is 5,200 milliliter per minute. Heart rate 76, and diastolic volume 145 milliliter. So we have to work out this, right? And we're going to use some formulas. And this is what I'm thinking, okay? So this is what we're going to find. We have to find the end systolic volume, right? We have to find the end systolic volume. And right now we know we know what end diastolic volume is. We don't know what stroke volume is. If we know what the stroke volume is, we can work out everything. And from my information we have, we can work out the stroke volume because right here, I'm going to use this. So I'm going to use this formula. I'm going to use this formula right here first, and then when I get the answer to the stroke volume, I'm going to plug my stroke volume in here, and then I'm going to get the end systolic volume, right? Over here, cardiac output is stroke volume times heart rate. We have this. We have cardiac output. We don't have stroke volume, but we have the heart rate. So we're going to use this formula first, right? So here's what we're going to do. So we're going to use this formula. So we're going to use this formula. Cardiac output is stroke volume times heart rate. So cardiac output is stroke volume times heart rate, right? And we have cardiac output right here, 5,200, and we have heart rate right here, which is 76. So we're gonna put them in. So we're gonna put them in this formula. So right, we're gonna put cardiac output, which is 5200 equals stroke volume that we don't know that we're gonna try and find that times heart rate, which is 76. Right? This is what we have. Cardiac output equals stroke volumes times heart rate. So we plug it in. We plug the number in. Stroke volume is 5200, and then equals stroke volume times 76. So what are we going to do now? We have to isolate this, right? This is just pure math. So stroke volume. So we're going to divide both sides right here by 76, right? 76. So we have 5200 divided by 76 equals stroke volume. So 5200 divided by 76 equals stroke volume. So I'm going to get my calculator out. Have a little calculator right here. So I'm going to put 70, hold on, clear. 5200 divided by 76 equals, so 68.42. So 68.42, right? So stroke volume is 68.42. So here you go. Stroke volume 68.42. So now I have my stroke volume, right? So I got my stroke volume. What I'm going to do? Once I have my stroke volume, I'm going to put my stroke volume in here, and then we have the end diastolic volume already from the question. So I'm going to be able to find the end systolic volume. So I'm going to use this formula now, right? So stroke volume equals end diastolic volume minus end systolic volume, right? So it makes sense, right? stroke volume is end diastolic volume minus end systolic volume. So that's the difference. So stroke volume is whatever is being pumped out of the left ventricle per beat, right? So if I use this formula now, right? Stroke volume equals end diastolic volume minus end systolic volume. I can find the end systolic volume, right? So I just plug in the number. So we have a stroke volume which is 68.42 equals end diastolic volume. End diastolic volume is given the question. End diastolic volume is 145 milliliter. So 145 milliliter minus end systolic volume. So I'm using this formula. Stroke volume equals end diastolic volume minus end systolic volume. So stroke volume we worked that out. Stroke volume is 68.24 equals end diastolic volume. We were given this 145 milliliter minus end systolic volume. So we're gonna try and find this out. Okay. So this is the equation. So the equation is 68.42 equals 145 minus n systolic volume, right? So this is just math, right? So you move this to the other side, right? So 68, you have to like minus 145 on each side, 145. So you have 68. So you have 68.42 minus 145 equals negative n systolic volume. So basically, in math, when you do something on one side, you have to do it to the other side. So I want to move 145 milliliter over to this side. So I have 68.42 minus 145 equals negative n systolic volume. So I'm going to get my calculator out. So 68.42 minus 145 equals, so negative, so that would be negative 76.6. I rounded up, so 76.6. So I round the 5 up to 6 equals negative ESV. So now I have this, right? Negative 76 equals negative n systolic volume. So to get rid of that negative sign, I divided by negative 1 on both sides, divided by negative 1. So basically that just cancelled out, negative sides are cancelled out. So the answer would be n systolic volume equals 77, rounded up. I just round up 77 milliliter. So the answer to this question is n systolic volume is 77 milliliter. And the question, remember, it asked you how much blood is left in the left ventricle. And we worked it out just now that once this patient's left ventricle pumps blood out, at the end of the pump, at the end of the left ventricle pump, the blood that's left in that chamber is 77 milliliter. And as I said, I'll go over it again real quick. So the question that we have, the question right here, right, says if the cardiac output is 7.2 liter per minute, heart rate is 76 beat per minute, end diastolic volume is 145 milliliter, what is the end systolic volume? So asking after the heart's pumped, how much blood is left in the left ventricle, basically, right? And we have all this information. And what I did was I basically found the stroke volume first, right? Because like we have the cardiac output of the patient, we have the heart rate of the patient, so I was able to work out the stroke volume. And the stroke volume of the patient was what? I worked that out as the stroke volume I worked it out as 68.42. So once I have the stroke volume, I plug the stroke volume into this formula, and this formula says stroke volume equal end diastolic volume minus end systolic volume, right? So I put the 68.4 that we worked out as the stroke volume, and end diastolic volume, we had that was given to us. End diastolic volume was in the question it gave us as 145 milliliter, right? So I put that 145 milliliter, and then this is just basically math. So have the stroke volume right here equals diastolic volume minus end systolic volume. So I just did the math. Now I isolated everything on one side, and it gave us the answer to 77 milliliter, right? And as I said, these terminologies are very important too, right? Cardiac output is the volume of blood that your left ventricle is pumping out to the rest of the body per minute. And end diastolic volume is the volume of blood when your left ventricle dilates, when your left ventricle receives blood before it pumps out. How much blood is in there? That's the end diastolic volume. And end systolic volume is when your left ventricle pumps blood out to the rest of your body after the pump. How much blood is left in the left ventricle? And these physiology problem is very important, and it doesn't take long to work out. But you just have to have like the basic knowledge and the basic understanding of your physio, and of course remember the formula, and you need you need to have an idea of what you're looking for with these questions, because sometimes you need like 2 or 3 formulas to work out each problem. But it's not difficult, because as I said, like you're gonna be given the numbers, you're gonna be given the heart rate, given the cardiac output. Like you're gonna be able to work things out once you have all these numbers that they give you, and then you look at the question stem, then you can work out what they want to ask. And as I said, the concept of stroke volume, ejection fraction, cardiac output is very important, and it's very easy to apply. As I said, stroke volume, that's the volume of blood that leaves the left ventricle per minute, per beat. Boom, 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 right? Per beat, how much blood is leaving that? How much blood is leaving your left ventricle per beat? Ejection fraction, it's a fraction that tells you the efficiency of your contractility of the heart, like how's the heart's working, right? And the normal ejection fraction is around 55%. And anything below that means that your heart is not pumping efficient enough. Something below that makes, it tells you that your heart, maybe something's wrong with the cardiac muscle, maybe you're having heart failure, something like that. So if anything's below 55%, that means that the patient's not getting enough blood, getting enough nutrients, getting enough oxygen to the rest of the body, right? And cardiac output measures the amount of blood that leaves the left ventricle per minute, right? Per minute. So it's a time thing, As I said, stroke volume is per beat, how much blood is leaving your heart. Cardiac output is per minute, how much blood is leaving per minute, right? And as you can see, like with this question, cardiac output of this patient, 5.2 liter per minute. And if you convert the liter to milliliters, what? 5,200 milliliter per minute. That's a lot of blood, right? So I guess that's it for today. And I hope you learned something about cardiac physiology, and I hope you know that you have a better understanding of how you work these things out, especially when you're sitting for your USMLE step 1. And this is very important concept for your step 1. And if you have any further questions or anything like that, you can message me on Facebook. And I think that's all I have for today. And it's nice to talk to everybody. And hopefully next time we'll do some more Facebook Live. And next time we can talk in Thai as well. And I just want to say good luck to everybody who's studying for your exam, and keep on studying hard. Okay, I think that's all I have for today. สวัสดีครับ